I'm going to teach some problems of exercise 2.4 of triangle chapter. Exercise 4. Okay, in that first question is, let triangle ABC is congruent to triangle DEF and their areas be respectively 64 centimeters square and 121 centimeters square. If EF, that is side EF, is 15.4 centimeter, find BC. Okay. First, I will draw two triangles. This one is triangle ABC and second is triangle DEF. So I will name the endpoints as A, B, C, and for the next one D, E, and F. Okay, these are the two triangles. What is given? First one I will write the given data as triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF. This is the first given point. The next one is the area of these two triangles are 64 centimeters square and 121 centimeters square. That means for the first triangle area is 64 centimeters square, and for the second triangle, this triangle DEF, it is 121 centimeters square. That is area of triangle ABC, that is equals to 64 centimeters square. That is the first triangle area, and area of triangle DEF, that is equals to 121 centimeters square. The third data given is side length EF is 15.4 centimeter. EF is equals to 15.4 centimeter. And in theorem we learned that the area, the ratios of the area of the two triangles, that is equals to square of the corresponding sides of ratios of the corresponding sides of the triangle. That is area of triangle ABC divided by area of triangle DEF, that is equals to, so here one side is given, that is EF, that is why I will consider BC, that is corresponding sides of these two triangles. In triangle DEF, if I consider EF as a side, then in triangle ABC I will consider BC as the side, because we need corresponding sides, and the ratios of the areas of the two triangles, that is equals to the square of the corresponding sides of that two triangles. So that's why in triangle ABC I will consider BC square, and in triangle DEF I will consider EF. Okay, just look at the step. So what are the given data here? The first one is triangle ABC is congruent to triangle DEF, and the second one, area of triangle ABC is 64 centimeters square, and area of triangle DEF is 121 centimeters square, and side length EF is 15.4 centimeter. And if you consider according to the theorem the ratios, then area of triangle ABC divided by area of triangle DEF, that is equals to BC square divided by EF. So now area of triangle ABC is given, that is 64 divided by area of triangle DEF, that is 1, that is equals to BC square, we don't know the value, write as this BC whole square divided by EF. EF is 15.4. So here I will write 15.4. Okay, this is the substitution method. Now we have to find out the value of BC. Okay, so for that we have to first reduce the equation for BC square. So here BC square becomes, so these two terms So here 15.4 whole square is in the denominator part. So when it goes to other side of the equality sign, it becomes multiplication. Therefore, it becomes 64 into 15.4 whole square divided by 121. Okay, just look at here. So we want only BC square. So the remaining part is 15.4 whole square, that is in the denominator. We have to shift that denominator term to the left hand side. So when it goes to other side of the equality sign, so here this division on that side becomes multiplication. So that's why it is 16.4 whole square divided by 121. The next simplification, that is BC equals to, now it is BC square. Now BC equals to square root of, because x square is equals to 4 means x equals to square root of 4, and square root of 4 value is 64 into 15.4 whole square divided by 120 divided by 121. That's why BC becomes 64 means 8 square is 64. 8 8s are 64. Okay. So 8 square we have to multiply it 2 times. So then it gives 64 as the answer. That's why it is 8 square. When 8 square comes outside the square root sign, it becomes 8. Similarly, 15.4 whole square. So when 15.4 whole square comes outside the square root sign, it becomes 15 divided by square root of 120. And we know that square root of 121 is 11 square. So when 11 square comes outside the square root sign, it becomes 11. Now we have to multiply 8 and 15.4, and after that we have to divide that with the help of 11. Then it gives the answer as 11.2 centimeter. 11.2 centimeter. Just look at the steps. So here BC square is 64 into 15.4 whole square divided by 121, and BC becomes square root of 64 into 15.4 whole square divided by 121, and when 64 comes outside the square root sign, it becomes 8, and 15.4 comes outside the square root sign, it becomes 15.4, and 121 is 11 square. When it comes outside the square root sign, it becomes 11, and if you multiply 8 and 15.4 and final product, if you divide that with the help of 11, you will get BC as 11.2 centimeter. Then I will consider the second problem. Diagonals of a trapezium ABCD with AB is parallel to BC. So in trapezium means the two sides are parallel to each other, and the remaining two sides are equal to each other. It is a trapezium ABCD with AB is parallel to BC intersect each other at the point O. If AB is 2 times of CD, find the ratio of the areas of the triangle AOB and COB. I will draw one trapezium. I will name the endpoints as A, B, C and D, and I will draw the diagonals EC and B. It is given that diagonals of trapezium ABCD with AB is parallel to DC. AB is parallel to DC. This is the first given data. They will intersect each other at the point O. So I will call this point as the intersected point. So which intersection of the two diagonals AC and BD, that is O. If AB is 2 times of CD, AB is 2 times of CD. So CD is CD plus CD, that gives 8. So that means length is 2 times. Then we have to find the ratio of the areas of the triangle AOB and AOC. We have to find the ratio of AOB and COD. Okay, this is the trapezium. Second problem. So first we will write the given data. In trapezium ABCD, AB's in trapezium ABCD, AB is parallel to CD, AB is parallel to CD, and diagonals AC and BD intersects at point 2, intersects at point O, and also given that AB is equals to 2 times of C. AD is equals to 2 times of C. This, look at the given data. Now we have to prove these two, the ratios of the areas of triangle AOB and DOC. We have to. So consider triangles. Consider triangle AOB, that is first triangle, and triangle COD, and triangle COD. These are the two triangles that is considered. Now first we will prove they are similar to each other. Okay, I will consider the angles, alternate angles. So because AB and CD sides are parallel to each other, so when the two lines are parallel to each other and they are intersected by a transversal, okay, transversal means here the diagonals, then the alternate angles are equal to each other. Therefore, I will treat these two angles as equals to each other in the triangle AOB and the triangle COD. Therefore, angle ABO, that is equals to ABO means this angle, that is equals to CDO. So this is one alternate angle. The next I will consider angle OAB and OCD. So they are also equal to each other because AB and CD are two parallel lines and they are intersected with the transversal AB. So therefore, angle OAB, that is equals to angle OCD. What is this? Alternate angles. Reason is alternate angles. The next, these two angles are equal to each other because they are vertically opposite angles. 1, 2, 3. Because they are having different angle, that's why I use different symbols. So angle AOB, that is equals to angle COD because they are, reason is vertically opposite angles. Therefore, we can consider triangle AOB is similar to triangle C. AOB is similar to triangle COD. Now what we have to do? Find the ratio of the areas of the triangles AOB and COD. So for that, I will consider area of triangle AOB divided by area of triangle COD, that is So I will consider this one, AB and CD, because in triangle AOB, AB is given, and in triangle COD, CD is given, or that relationship is given. So that's why I will consider in AOB, AB whole square divided by in COD, CD whole square. Just look at the board. Once again, I will explain. So here in a trapezium ABCD, AB is parallel to CD is given. Then AC and BD intersect. That means the diagonals intersect at point O. And also given that AB is 2 times of CD. Now we have to do the ratios. So that's why I'll consider triangle AOB and triangle COD. In the two triangles, angle ABO, that is equals to angle CDO, and angle AOB, that is equals to angle OCD, because they are alternate angles. Because given that AB is parallel to CD, and if two parallel lines are intersected by transversals, then the alternate angles are equal. So because of that, these two alternate angles are equal. And next one, when the two lines are intersect with each other, then the vertically opposite angles are also equal to each other. Therefore, angle AOB, that is equals to angle COD. So here these angles are equal. Therefore, we can consider triangle AOB is similar to triangle COD. And according to theorem, we know that the ratio of the areas of the two triangles, that is equals to ratios of the square of the corresponding sides of that two triangles. That's why it becomes area of triangle AOB divided by area of triangle COD, that is equals to AB square divided by CD square. So say area of triangle AOB divided by area of triangle COD, that is equals to AB. AB value is given 2 times of CD. Here it is AB square, that's why 2 times of CD whole square divided by CD. Don't cancel the CD and CD. First we have to square. After that only we can able to cancel the terms. That's why it becomes area of triangle AOB divided by area of triangle COD, that is equal to 2 square is 4, then CD square divided by CD. Now CD square gets cancelled. Remaining is area of triangle AOB divided by area of triangle COD, that is equal to 4. Nothing is present in 1. That means ratios of the two triangles is 4:1. Therefore, area of triangle AOB is 2. Area of triangle COD, that is equals to 4:1. That is equals to 4:1. This is the solution for second problem. Okay, just look at the steps once again. Then I'll move to the third problem. Just look at the question. Here is the third question. Third one, in the figure, ABC and DBC are two triangles on the same base BC. If AD intersect BC at point O, show that area of triangle ABC divided by area of triangle DBC, that is equals to AO divided by D. So again, one trapezium is given. A, B, C, D, and then diagonal is given. Okay, is BC, that is given data. That triangle ABC and DBC given. Triangle ABC, that means the upper triangle, and lower triangle is DBC, and triangle DBC are present on same base BC. So here ABC is on the base BC and DBC is on base BC. Okay. Are present on same base BC. The next one is if AD intersect BC at O, AB intersect BC at O, we have to show the ratios of the two triangles. AD intersects BC at point O. Okay. Then I'll consider one line AM which is perpendicular to BC and AM. DN, that is perpendicular to BC. Let AM is perpendicular to BC and DN perpendicular to BC. Okay, these are the two triangles which are perpendicular, and here we consider line AM and DN, they are perpendicular to each other, to the base BC. Now I consider triangle is O. Okay, the second point is O. So I'll consider triangle AMO or AOM. Consider triangle AOM and triangle DOM. I consider these two triangles. So here it is perpendicular, that's why the angles are equals to 90 degree. So I will consider that theory here. Angle AMO, that is equals to DNO, that is equals to 90 degree. Reason is by construction. Then next one is here these two lines are intersected with each other, therefore vertically opposite angles are equal to each other. That's why I consider angle AOM, that is equals to AOM, that is equals to DON. Reason is vertically opposite angles. Okay. See here, ABCD is a trapezium, and in that triangle ABC and triangle BDC present on the same base BC, and diagonals AD and BC intersect at point. This is a given data. So I consider line AM which is perpendicular to side BC and DN perpendicular to side BC. Then I consider triangle AMO and BOC. DON. Okay, AMO and DON. Here these two angles are equal to 90 degree. That is angle AMO that is equal to DNO that is equal to 90 degree by construction, and angle AOM that is equal to angle DON that is because of vertically opposite angles. Therefore, when these two angles are equal, then we can take the triangle AOM that is similar to triangle DON. Therefore, triangle AOM that is similar to triangle DON. Reason is by AA, that is AA means angle. Similarity, criteria. Angle similarity criteria. When the two triangles are similar, then the side ratios are also equal to each other. Therefore, I will write AM divided by DN that is equals to AO divided by DN. That is equals to AO divided by DN. So I will call this as equation 1. So when the two triangles are similar to each other, then the corresponding sides are in the same ratio. That's why AM divided by DN that is equals to AO divided by DN. Now I consider the triangle ABC and triangle BC, and I will apply the formula to find out area. That means I will take the ratios of the areas of the two triangles. Area of triangle ABC divided by area of triangle BDC. So which formula we have to use? We have to use half into base into height. So half for triangle ABC, half, base is BC and height is A, that is perpendicular divided by, for triangle BDC again half into base into height, half into base is again BC and height is DN. So therefore half of gets cancelled, BC gets cancelled. That's why remaining is area of triangle ABC divided by area of triangle BDC, that is equals to AM divided by DN. Area of triangle ABC divided by area of triangle BDC, that is equals to AM divided by DN. Okay, this formula I use half into base into height. That is area of triangle ABC divided by area of triangle BDC is equals to half into base is BC into height AM for the first triangle, and for the denominator triangle, that is triangle BDC, area is half into base BC into height DN. So half gets cancelled, BC gets cancelled. So remaining is AM divided by DN. But from equation 1 we can write AM divided by DN, that is equals to AO divided by DN. From equation 1, AM divided by DN that is equals to AO divided by DN. That one we have to do. Now we will substitute that value, that is AM by, instead of writing AM by DN, we will write AO divided by DN. Therefore, area of triangle ABC divided by area of triangle BDC, that is AM by DN means AO divided by D. And congruence. Okay, this is the third problem solution. Just look at the steps. Then read the fourth question. Fourth one. So if the areas of two similar triangles are equal, so I'll consider two triangles. Okay. A, B, C, and next one is D, E. Triangle ABC and triangle DEF. If the areas of two similar triangles are equal, prove that they are common. Fourth solution. First given data is the area of two similar triangles. That means triangle ABC is similar to triangle DEF. Given triangle ABC is similar to triangle DEF. Triangle ABC is similar to triangle DEF. This is the given data, and it is given that the area of the two similar triangles are equal. That's why the area of triangle ABC, that is equals to area of triangle DEF. Area of triangle ABC, that is equals to area of triangle DEF. Area of triangle ABC, that is equals to area of triangle DEF. And when the triangles are similar, then the ratios, square of the corresponding ratios are also equals to each other. That's why I write area of triangle ABC divided by area of triangle DEF, that is equals to. So I will consider AB and CD. AB and DE, they are corresponding sides. That's why AB square divided by DE square, that is equals to, second side is BC, so that's why I will consider BC square, and then second triangle, the second side is TF divided by TF whole square, that is equals to third side. The first triangle is KC, that's why it is KC square, and the second triangle is DF. Okay. The areas of the two triangles are equal, it is given, and when the two triangles are similar, then we can write the ratios of the square of the corresponding sides are also equals to each other. And now we have to prove the two triangles are congruent to each other. So here area of triangle is, let's say, equals to area of triangle DEF. That's why these are equal, and that becomes 1. That is 1 equals to AB whole square divided by BE whole square, that is equals to BC whole square divided by EF whole square, that is equals to AC whole square divided by df. So all the values are equals to 1. So therefore when we consider only this part, that is 1 equals to ab square divided by b square. Okay, this implies that, so when you cross multiply it becomes ab whole square, that is equals to de whole square. ab whole square, that is equals to de whole square. When we take square root on the both the side, it gives ab equals to d, that is ab equals to de. Similarly, when you consider bc square divided by af square, that is equals to 1, we will get bc equals to af, and when we consider ac square divided by df, ac square divided by df square, that is equals to 1, we will get ac equals to df. So here ab equals to de, bc equals to ef, ac equals to df. Therefore the three sides of the triangles are equals to each other. Therefore when you consider side criterion, you will get triangle ABC is congruent to triangle DEF. Therefore three sides of the two triangles are equal. Therefore by SSS congruence rule, triangle ABC is congruent to triangle DE. Triangle ABC is congruent to triangle DEF. Hence proved. Let's look at the steps once again. So areas of two triangles are similar, it is given, and also areas of the two triangles are similar and areas of the two triangles are equal, it is given. So that's why when you apply the theorem, it becomes area of triangle ABC by area of triangle DEF, that is equals to AB square divided by DE square, that is equals to BC square by EF square, and that is equals to AC square by AF square. And area of two triangles are equal, that's why the two terms gets cancelled and remaining is 1. That's why all the values of the corresponding ratios, square of the ratios of the corresponding sides are equal to 1. And when we take the values individually to equal to 1, then we will get AB equals to DE, and similarly BC equals to EF, and AC equals to DF. Therefore, three sides of the two triangles are equal, and by using SSS congruency rule, we can write triangle ABC is congruent to triangle DEF. That is the required thing. Given that triangle AB is similar to triangle DEF, and we have to prove triangle ABC is congruent to triangle DEF, and we proved that. Okay, thank you dear student. I will continue the remaining in the next class.